Hey, I'm your friend who is teaching you to pass your exam on ESTC paper of BS in ES IIT Madras curriculum. Alright, we have got week 1 to week 12, but now we are going to focus only on the week 1. Very basic, very easy. I will be focusing only on the core concepts, high yield formulas, and problem solving shortcuts that make you score more or at least make you pass your exam if you haven't touched anything. And I would suggest you to stop rewatching the lectures of our professors and save your precious time by solving more questions and just revise the concepts. And this video is exactly designed in that way. All right, so let's start with the ESTC week 1 content without any time waste. First, assume water and water tank. Water inside the water tank, you assume it as a charge. All right, water flows inside the tank the same way charge flows inside the wire. The flowing of charge, we call it as current. There is a pressure inside the water tank. The same way the charge feels pressure, and that pressure is what we call as voltage. We have resistance inside the water flow, right? The same way while the charge is moving, there happens resistance, and we call it as resistance and we denote it as R. So QIVR. So this simple analogy will help you to feel more intuitively the concept of charge, current and all. Alright, so let's focus on the charge now. Charge is of two types. One is positive, other one is negative. SI unit of charge is coulomb. One electron charge is 1.6 into 10 power minus 19 coulomb, and 1 coulomb have 6.24 into 10 power 18 number of electrons. This is huge, right? Now let's understand current. Current is nothing but the rate of flow of charge per unit of time. How much amount of charge is moving, this is said by the current, and the current unit is ampere. We have got sign convention for the current. We know the electron move from negative terminal to positive terminal, whereas the current move from positive terminal to the negative terminal. All right, now let's focus on voltage. Voltage is nothing but the work done to move certain amount of charge or per unit of charge. The 1 joule of work is done per coulomb of charge is nothing but voltage, and we call it as a potential difference. Okay, potential difference is the main thing because of which current is flowing. You already know the water flows from higher height to the lower height. For example, from the mountains as a waterfall to the river, right? So this is a height difference. The same way voltage is also responsible for the flow of current. It generates a potential difference. Because of this difference, the current will flow from high potential to lower potential. From higher potential to lower potential, current is flowing because of voltage. The same way water is flowing from higher heights to lower depths. This is because of the height difference. The same way voltage helps the current to flow. This is very basic. How much charge is moving is said by how much amount of charge is said by, how much amount of charge is moving per time is said by current, whereas how much energy per unit of charge carries 1 joule, like how much energy per unit of charge carries is said by voltage. Now understand this very clearly. Voltage does not actually create current or does not cause current. This is very important. Voltage just creates something called as an electric field. This is a field or an area where the charges move, the electrons move, and we know the movement of electrons is current. So voltage doesn't cause the current, it creates electric field. Because of the electric field, charges move. Because of the movement of charge, that creates current. Now let's understand the power. Power is nothing but the rate of doing work. With what speed you do particular work measures your power, correct? So power can be measured as voltage into current. Okay, or you can write energy by time. This is the formula for power. And the SI unit of power is watts, and you can also write joule per second because energy is joule and time is in seconds. Now, what is energy? It is nothing but the total quantity of energy consumption. You must know the difference between power and energy, because the speed with which you do certain work will be measured by your power, and the quantity of energy you consume in order to do that work determines your energy, and energy is nothing but PT, power into time, and the SI unit is joules. Watt hour is the SI unit of energy. And remember one thing, you should not use time in seconds when you calculate energy. You should be keeping in your mind that time should be in hours. All right. And one more thing I want to tell you, many people forget many people write ESP by T. This is wrong. One of my friends told me that we in our school days we had PT period, right? PET actually, but PT period. Whenever someone is saying PT period to you, you'll be like E. You will be showing your teeth, right? So it's like E. So so whenever someone is telling you PT period, it's E. Or when it is E, it's obviously PT. Alright. So then so far we have learned few formulas. That is, current is charge by time, voltage is work by charge, power is P into I, E is PT, and E is, you can write power, you can say power is VI. So instead of power you can write VI into T. Yeah. Now let's talk about the Ohm's law. Ohm's law is very basic, you have learned in earlier classes. So V is equal to IR. Instead of V you can write IR, and instead of I you can write V by R. So what happens? Instead of V I am writing IR. So P is equal to IR into I, that equals I square R. The same way P is equal to, instead of I am writing V by R. So V into, instead of I, V by R, it's going to be V square by R. So we have got two formulas. P is equal to I square R and P is equal to V square by R. Alright, and I want to let you know these the units. Before that, let's focus here. You know, PT is E. You have already learned P is equal to VI and I square R and V square by R. Just inculcate these values of P in the formula of energy. You get VI, I square R, V square by R, and T follows. Okay. And one more thing, very important, the unit is watt hour. Every time term here should be in hours. Until and unless the question specifies in seconds, just go for hours. Alright? That's great. Now let's move on to the units. This is very important. You know milliampere, right? Ampere is nothing but current. Milliampere is like 10 power minus 3 of current. You know that. But listen to me very carefully. 10 power 3. In order to convert the ampere to milliampere, you should multiply it with 10 power 3. Now, am I correct? Yeah. Now, let's understand milliampere hour. What does it mean actually? It is nothing but current into time. Isn't it charge? Yes, it is charge. So, it is denoting the charge stored. And what is volt? It's generally the voltage. It is the potential difference. It is the pressure. How strong is the push, denoted by volt. What is watt hour? We just learned watt hour is the unit of energy. So total energy stored is represented by watt hour. Alright, now let's learn few things related to the first week. Yeah. So you learned these formulas, VI, V square by R, I square R, PT, VIT, V square by RT, these things, and what our time is in hours. Alright, now let's learn about something new. Independent sources and dependent sources. Independent sources are the sources where the voltage and current are fixed regardless of the circuit. V and I are always fixed. Like they will be giving you the 5-volt battery or 12-volt adapter, so the voltage is fixed. And the same way current constant sources will be given, so current also will be fixed. So regardless of the circuit, if the voltage and current are fixed, then you are naming the sources as independent sources. Now, if the voltage and current depend on another sources elsewhere in the circuit, then we name them as dependent sources. Like transistors, integrated circuits are examples of dependent sources. What are these? These are nothing but voltage controlled voltage sources. So this voltage source is controlled by another voltage. The same way, voltage controlled current source, current controlled current source, current controlled voltage source. You get the point? Now that's easy. Now let's talk about the normal circuit and short circuit. This is very important. In the normal circuit, the current path will be through the appliance. If you have a refrigerator, the current flows into the refrigerator to make it work, alright? But in case of short circuit, it will not enter to the appliance. It will not enter into the refrigerator. It just bypasses it. The resistance here is high. Resistance here is high. The resistance in the short circuit is low, okay? The current which is moving, because the resistance is high, the current will be a normal amount, like the normal quantity of current will be passing through the refrigerator. So it is safe. The appliance functions normally. But as the resistance is low, the current is dangerously high. The fuse, spark, fire will happen because the current is not entering the appliances. It just bypasses the appliances because of the short circuit. The current is dangerously high. As the resistance is low, that happens fuse, sparks and fire. Alright? That's very easy. Now let's focus on very simple concept. This is very basic. Like we have two elements. Before talking about the elements, let me talk about the networks and circuit. Alright? So listen friends, listen. What I have written? Okay. Any combination of interconnected electrical components constitute network. It doesn't mean you can have a battery, you can have a resistor, you can have a bulb, etc. etc. Like any combination of they are connected together, alright? Any combination of interconnected electrical components, we call them as network elements. What is a circuit element? Circuit is nothing but specific type of network. Circuit is a type of network. Circuit is a type of network that contains at least one closed loop. If it is starting with a battery, a bulb, and a resistance, and a voltage ammeter, and then the circuit closes. You understand? So, specific type of network that contains at least one closed loop for the current to return to the source. So, this is a circuital element. Now, listen to me very carefully. All circuits are networks because I told you circuit is a type of network. So all circuits comes under the type of network. So all circuits are networks. But all networks are not circuits because it is not necessary for a network to have a closed loop, right? It is not necessary. So we can't call all networks as circuits. That's great. Now let's understand another basic concept. Network elements are of two types. One is active, other one is passive. If you talk about the active network elements, either they generate or supply or amplify the electrical energy. Generate, supply or amplify the electrical energy, like battery, transistors and all. The passive network elements only consume or dissipate or store electric energy. Either they consume or dissipate or they store, like resistance, inductance, capacitance, like that. Inductor, capacitor, like that. You understand? So whoever is generating or supplying or amplifying the electrical energy like battery and transistor, they come under active networking elements. Which are elements are consuming, dissipating, storing, like resistor, inductor, capacitor, they come under passive networking element. You get the point? That's great. So we have done with these. Now this topic is very basic. You know, your friend might have a fast charger, right? What does it mean actually? That particular charger is providing more charge per unit time, which means more current. or more energy per unit time, which means more power. You understand? That's the reason why their charger is charging faster, which means the supply of current, the supply of charge, the supply of energy is more. You understand? Now, charging speed depends on current rating as well, not just on voltage. It depends on the current rating as well. Many charger will have the 15 watt. In many charger, you might have seen 45 watts, 90 watts, 120 watts. As the watt increases, the speed, the charging rate of the charger increases. Okay, the current rating is nothing but, I might have mentioned 5 ampere, 7 ampere, mostly 5 ampere. Not just voltage, many charger connect 15 volt like that. So not just voltage, the charging speed also depends on the current rating, because current depends on the number of charges. So as the number of charges increases, the speed of the charger increases. So charging speed also depends on the current rating. You understand? And in the lecture, professor was explaining the infotainment USB in the car, right? What happens? Why the infotainment battery is not making our smartphone charge? Because the required current is more for our smartphone to charge. It needs around 5 ampere, like 3 ampere to 5 ampere at least. But the infotainment USB is supplying like minimal amount of ampere, like in terms of milliampere it is supplying. So our phone will not get charged. When the supplying current is more than the required current, you can charge your smartphone or any appliances. You understand the point? Now, what is discharging and charging? This is very basic, you know it. What is discharging? A chemical energy when it is converted into electrical energy, which means what? Technically, the chemical energy inside your battery will get converted and stored as an electrical energy. What is charging? Charging is nothing but that stored electrical energy will be converted to a chemical energy. Like, listen to me. The battery will be, whenever it is idle, the chemical reaction takes place and that gets converted to an electrical energy, and that we call as discharging. What is charging? From the wall, from the switchboard, from the switch you connect the wire and all. From that, electrical energy is converted to chemical energy. Like inside the battery, the chemical energy created. And whenever it is idle, the chemical energy will get converted to electrical energy. You understand? This is discharging and charging. That's very easy. Now let's talk about battery and charger. Battery is nothing but energy storage device, right? Battery is nothing but energy storage device, whereas charger is nothing but electronic device which can have the capability of converting high volt alternating current to low volt direct current. This is what a charger does, people. This is what a charger does. It is a tool that converts high volt AC to low volt DC. Think of the charger as a water pump, alright? Think of a charger as a water pump, like a motor. Whereas the battery is just a storing device, like a water tank. And the charger, we represent the unit with watt. The 120 watts charger has more potential of charging than 15 watt or 40 watts, right? And the battery, we know it's measured in terms of capacity or energy. We have these two units, alright? So what else left? I forgot to tell you about this. We have got two elements. One is linear and non-linear. Linear elements are these elements which follows Ohm's law. Like if we plot VI graph, the graph will follow Ohm's law. If the current doubles, voltage doubles. If the current get cubed, the voltage get cubed. You understand? And these linear elements follow additivity and homogeneity rule, like resistors, inductor, and capacitors. Like, for example, the non-linear elements are nothing but they don't follow Ohm's law. They are the rule breakers, and the examples are diode and transistors. Their graph looks somewhat like this. Alright, so that's it. These are the main core concepts delivered in the week 1 content of ESTC. I hope you understood few things. Now let's quickly jump into the questions. Alright. After solving these questions, let's focus on the solving practice and graded assignments. Are you ready? Let's start. A resistor draws 3 ampere Current is 3 ampere. From a 15 volt battery, how much power does the battery delivers to the resistor? We are supposed to find the power. P is equal to IV. You know that. 15 into 3. Now, next question. A heater draws current 15 ampere when connected to a 230 voltage line. How much time in seconds will it take to consume the energy of 50 kilojoule? Remember, the unit is very important. Kilojoule they are asking. Alright, that's very easy. What do you think? How can we solve it? We know P, T, E is PT. I told you. So P is VIT because P is VI. We have learned it. We have learned this. So what is V here? What is I here? What is E here? We are supposed to find the time. So E by VI is time. So it is 50 kilojoule means we are supposed to convert it into joule so that we can get the time. Yeah. So it is nothing but 10 power 3. 10 power 3. What is what? 230. What is current? Current 15. Solve it and you get the answer as this. Alright? I'm sorry. Now let's talk about this question. One second. Okay. Find the energy, okay, stored in a 12 volt battery rated at, what is this? Tell me what is this? This is current into time. This is charge. Yeah. Q is 600. And they're asking us energy in watt hour. I told you already, QV is the formula for energy. So 12 into 600. You want me to calculate? Where is my calculator? 7200 actually. Okay, fine. Next question. A DC motor consumes 40 milli. I'm sorry guys, it is megajoule when connected to 250 volt for 1 hour. Okay, what are we supposed to find? Find the power rating in kilowatt. We are supposed to find the power. How can we do that? Do you have any idea? Power is equal to energy by time, that we know it. Yeah. So what is energy here? 40 mega, which means 10 power 6 joules. And time is in 1 hour. Yeah. What do you think? Are you supposed to write the time in hour? No, definitely no. It should be in seconds. So 1 hour is 3600 seconds. Because you know power is watt and watt is nothing but joule per second. They have given 1 hour, convert it into seconds. Alright? Solve it. You want me to solve? Just do the calculations, okay? Fine. Next question. An electric kettle has a resistance 20 ohm. 20 ohm. What current in ampere will it flow? Will flow when it is connected to? They are asking the current when it is connected to 240 volt supply and find the power rating of the kettle. We are supposed to find the two things. One is current, other one is power. Shall we? V is equal to IR from Ohm's law and I is equal to V by R. We have given with volt as 240 and resistance is 20. We have got the current. Yeah, it's 12 ampere. Now, we are supposed to find the power. Power is VI. We have got V as 240 and current is 12. You know that. That's easy question. Now, how long it takes in seconds? In seconds. How long means time. For 100 millicoulomb, 100 millicoulomb is nothing but charge. Coulomb means charge. To pass a point, if the current is, this is very easy, 25 milliampere. Listen, when I went to an exam, I wrote this formula wrong, like this basic formula. I was running out of time, so I wrote this formula incorrectly. Like, I messed up somewhere. I regret till date. Okay, so it's 100 by, no way. They're asking us the time, so 100 by 25 is 4. Alright, now let's move on to the next question. A heater coil takes Okay, a heater coil takes 10 minutes to heat a certain quantity of water, increases the temperature by 10 degrees Celsius. So let's take the heater coil 1. It is taking 10 minutes, alright, to increase the temperature by 10 degrees Celsius. Another coil takes 5 minutes. So let's name it heater coil 2. It is taking how many minutes? 5 minutes for the same. For the same means for the 10 degrees Celsius. How long would it take to achieve the same temperature? How long would it take to achieve the same temperature rise, 10 degrees Celsius, if both coils are immersed together? We are going to immerse these two and we need 10 degree Celsius rise, and how much time will it take is the question. Alright? Nice question. How can we solve it? Okay, I feel like, bro, listen to me. If 10 minutes is used for increasing the temperature 10 seconds by 10 degrees Celsius, for 1 minute it will be 1 degree Celsius for the heater coil 1, and for the coil number 2, if it is taking 5 minutes for 10 degrees Celsius, then for 1 minute it will take 10 by 5 degrees Celsius. So it's going to be 2 degrees Celsius. So all I can say is heater coil 1 takes 1 minute to increase the temperature by 1 degree Celsius, and heater coil 2 is taking 1 minute for 2 degrees Celsius. And they're asking me to put heater coil 1 and heater coil 2. Okay, in 1 minute they will take 3 degrees Celsius. Yeah, but I want in how many minutes they will take to increase the temperature by another, how long would it take to achieve the same temperature? 10 degrees Celsius. 10 degrees Celsius. So it's nothing but 10 into 1 is equal to 3 into how many minutes? It's 10 by 3. It is 3.33 minutes. This question is a great question. Okay, so that's it. Let's focus on the practice and graded assignments in the next video. Thank you.